Hello everyone. In this video, you will learn how to build and simulate a boost converter using Simulink. I will take as an example a boost converter that has an input of 24 volts, an output voltage of 36 volt. This is my desired output voltage. The inductor size is 470 microhenry. The capacitor size is 220 microfarads, and the load is a resistive load with a resistance value of 30 ohms. The switching frequency is 150 kilohertz, and the calculated duty cycle is 33.34%. To start, we need to run the Simulink. We can do that by simply going to New and selecting a Simulink model, or by simply typing Simulink in the command window and hitting enter. After that, the Simulink will open. We go to create a blank model, and here we have the workspace of the Simulink open. To add the components, we need to open the library browser. We simply click on it. I'm gonna put the windows beside each other's. Okay, so the first thing we need is the DC voltage source. In the Simulink library browser, we have the Simulink library and the Simscape library. These are the two we are going to be using. So the DC voltage source can be found in the Simscape library under Electrical, Specialized Power Systems, and under Fundamental Blocks. We go to the Fundamental Blocks and select electric sources. And here we have the DC voltage source. Now to add this DC voltage source to our workspace, we simply click on it and drag it to our workspace, or we can right click on it and add it to the model. Now to delete a block in the workspace, we simply select it and press the delete button. You can move the block anywhere in the workspace by simply clicking on it and dragging it to the desired location. Now we need the storage elements and the load. We can find these in also the fundamental blocks under elements. I will select a series RLC branch. What we need is an inductor, a capacitor, and a resistive load. So we need 3 series RLC branches. We can simply add this block 3 times, or we can copy paste it by selecting it and then Ctrl+C, Ctrl+V, or simply click on it, press the Control button and drag it, and you will have another copy of it. To rotate a component or a block in the workspace, you select it and press on Ctrl+R. It's just Ctrl+R, not Ctrl+R. So we need an inductor. We double click on the series RLC branch. We select L, which is an inductor, and the value of the inductor is 470 microhenry. The capacitor size is 220 microfarads, and the resistive load size is 30 ohms. I also need to rotate this. We can change the name of the blocks by simply selecting them, double click on the text, and rename it. So here we have an inductor. capacitor and the load. So as we mentioned before, the value of the input voltage is 24 volts. Now we still need the diode and the MOSFET. We can find these in the library under power electronics. We want a diode and a MOSFET. We rotate the MOSFET and in the MOSFET we have the drain, the source and the gate terminals. We start connecting our components. We simply click on the terminals and connect them. Okay. Now to run the MOSFET, we need a pulse generator, which we can find under the Simulink library, under sources. We look for the pulse generator, and that's it over here. Another way to find a block is by simply searching for it here, or double-clicking anywhere in the workspace and typing its name. So we need a pulse generator, and that's it. Here we select it. This is my pulse generator. My switching frequency is 150 kilohertz, so I need to change the period. So it's going to be 1 over 150 kilohertz. And my duty cycle is 33.34%, which is also equivalent to 100 over 3. Now to measure the inductor current and the output voltage, we need the measurement blocks. We can find these also in the library under specialized power systems. So we click on measurements and we get the current measurement block and the voltage measurement block. We connect the voltage measurement block in parallel, and to delete a connector you simply select it and press the delete button. We connect the current measurement block in series, and to display these values we go to sinks under the Simulink library and we get a scope block. We can also display this using a display. So the scope will plot these values and the display will just display the number, the value itself, the instantaneous value. I need to add another port to the scope because I want to display the output voltage and the inductor current. To do that, I double click on the scope and go to the configuration properties under view, under the view tab. And I change the number of ports to 2. So now I have 2 ports for the scope. Now we can simply connect the measurement block to the scope, or we can use another. We can do it in another way to avoid the mass of all the connectors. We can do that by using the go to and from block. So I'm gonna get a go to block and I will connect the current measurement to it, and then from block to the scope. And since they both have the same tag, they will display the same value. So the value, the input, the inductor current that I'm reading from the voltage, from the inductor, from the current measurement will be sent to this block, which will also send it to the scope. I will also display the output voltage using the display block here. And to run all this, I need the Power GUI solver. So we can find that under fundamental blocks. Or we can simply search for it. And that's it. Now I need to run this for 1 second. So I will input the stop time as 1 second. And then to run this, I simply click on run. On the display block, I will see the instantaneous value of the output voltage. And once the simulation is finished, I will open the scope. I forgot to do one thing. I will change the name of the current measurement to inductor current and the voltage measurement name to output voltage, and run it again. Okay, so the simulation is finished. We open the scope. We have two plots. The first thing to do is to add the legend. So I go to view and then I select legend. So in yellow I have the output voltage and in blue I have the inductor current. And this is why I changed the name of the voltage and current measurement blocks. So to zoom in this plot, we can zoom in the X direction, in the Y direction, or we can just select this zoom tool and zoom anywhere we want. If I want to go back to the original view, I select this tool, which is scale X and Y axis limits. I will zoom in the X direction over here. And I will add some measurement tools, which are the cursor measurements and the signal statistics. So now we are looking at the output voltage, which is in yellow. And here we can select which values we are going to measure or get statistics for. For example, for the output voltage, if I select the output voltage, I have under signal statistics the maximum value, which is 64.7 volts. The minimum value is minus 4.8 times 10 to the power minus 4. And the mean is 35.31 volt. The desired output voltage was 36 volts, but due to non-idealities in the system, this is what we get. Now to use the cursor measurements, so I have two cursors, 1 and 2, and here I can see the values and the time. For example, if I want to read the value of the voltage at 0.01 seconds, I can enter 0.01 seconds and click enter, and the cursor will move to 0.01 second, and the value is 34.61 volts for the output voltage. I can also move the cursor anywhere I want to read the value. The same goes for the inductor current. the mean value of the inductor current is 1.8 amps. If I want to zoom to this area, so we can see how the voltage and the inductor current are varying before achieving the steady state. And that's it. Thank you.